Now let us consider the next topic, that is pericyclic reactions. Since majority of the reaction involving formation of ion or free radical intermediates which then changes into the product. However, there are some reaction which takes place without forming any kind of intermediates. Such type of reaction are known as pericyclic reaction. Consider an example for the pericyclic reaction. So this is 1, 2, 3, 4. So it is 1, 3 butadiene. It gives this product. Our second example we are going to consider. This is the product. Now these are the two reactions I am going to consider here. Now how we can define the pericyclic reaction from this reaction. So the pericyclic reactions can be defined. These are definition. These are one step reaction, one step concerted reactions involving cyclic transition state. Cyclic transition state without forming any intermediate. Without forming any intermediate. So now this is the definition for the pericyclic reaction. It is a one-step reaction and concerted process. So the concerted process means concerted reaction means bond making and bond breaking both takes place simultaneously. Both takes place simultaneously. So such type of reaction are known as concerted reaction. So this is the one step and concerted reaction which involves a cyclic transition state. So this type of particular reaction always involve cyclic transition state. Either it is 6 member, 5 member, depending upon the molecules. So there are few characteristics of pericyclic reaction. Now these are, that is one by one. So the characteristics of reactions. So the first characteristics. So these are reversible reactions. These are reversible reaction means they can go forward direction as well as backward direction. Reversible reactions. So second one characteristic is they involve the ring closure and ring opening also. They involve ring closure means ring closing and ring opening. So they involve ring closure and ring opening reactions. third characteristics, they are they are not sensitive to solvent and catalyst. Means they don't have any kind of effect by the presence of solvent and catalyst. They can run without catalyst and solvent also. Or we can say that catalyst does not affect the rate of reactions. The next one is these reactions are initiated by these reactions are initiated by are initiated by heat or by the presence of light that is H mu. Next one is these reactions are stereospecific reactions. These are stereospecific reactions. Stereospecific means specific isomer gives the specific isomer gives the specific product. So let us see this one by one. Now the next one is classification of pericyclic reaction. So the pericyclic reaction are classified different types depending upon their reactivity sites. So the first one is types of classification of pericyclic reaction. So first one is electrocyclic reaction. Electrocyclic reactions. Second one is that is cycloaddition reaction. Cycloaddition reaction. Third one is cheletropic reaction. Cheletropic reactions. The fourth one is that is sigmatropic rearrangement. Sigmatropic rearrangement. And the last one, fifth one, is a group transfer reactions. Group transfer reactions. Okay, these are the five class of pericyclic reaction. So we are going to consider one by one. The first one is electrocyclic reaction. First one is the first type of pericyclic reaction is electrocyclic reactions. Electrocyclic reactions. So these are the reactions which are reversible reaction that can be involved ring closure or ring opening. So it involves ring closure and opening also. So again, so let us consider the first one, that is ring closure reactions. What is meant by ring closure reaction? So again, electrocyclic reaction having ring closure type. So it is an electrocyclic reaction. It is an electrocyclic reaction. An electrocyclic reaction which is which involves intramolecular intramolecular reaction that forms a cyclic product containing containing one more sigma bond and one fewer pi bond than the reactant. So this particular type of reaction, ring closure type of reaction, electrocyclic reaction, it involves intramolecular reactions. So this is intramolecular reaction which forms a cyclic product which contains one extra sigma bond and one pi bond is less than that of the reactant. So these are the important points in this case. Students should remember that this reaction is intermolecular. Again, it involves a cyclic product. Okay, because it is a ring closure, so it always involves a cyclic product. But in the cyclic product, final product, one sigma bond is extra and one pi bond is less than as compared to the reactant. So this is the basic idea to identify the ring closure reactions. So let us consider an example. So this bond will migrate here and this bond goes here. So it involves a cyclic transition state like that. So this is the basic structure of ring, and now sorry. So these are the basic bonds. Now this is going to form new bond. Okay. Now this is double bond and this is again new double bond and this will be double bond. So this is a transition state. Now the product formation is here. This double bond is here. So it is 1,3-butadiene and it gives the butene. So see here, this reaction involves intermolecular bond migration. So initially it has two pi bonds, right? Now in this case it has one pi bond. So the one pi bond has one pi bond, and this particular type of bond is newly formed. So this is a new sigma bond. So the student should remember these things. After the formation of cyclic ring, the one pi bond is less than and the one new sigma bond is formed. So we can say that two pi bonds are used to form one sigma bond in case of ring closure type of reaction. Let us see another example. So this bond will migrate here, this bond will migrate here, this bond will migrate here. Okay, we are going to the number rings, that is 1, 2, 3, 4, 5, and the 6 carbons are there. So the see the position of double bond. Here it is 1, here it is 1, here it is at the 3 position double bond start, and here it is 5 position. So the name of this ring is 1, 3, 5, that is, and total number of carbons are 6, so it is a hexa, and the 3 double bonds are there, so it is a trine. So it is 135 hexa, and the intermediate form is, so this is the 6 member transition state, and the intermediate form is like that. This is a transition state, this is also TS, a 4 member, and this is transition state which having 6 membering, 6 member. Now the 6 member transition states are the most stable transition states, and the final product is, okay. Now the newly formed double bond I am going to represent with the red mark. So this is the bond position newly formed, this is the bond position, and this is the new bond. So this is the new sigma bond is formed, new sigma bond is formed. So in this case there are 3 pi bonds. Now in this case there are 2 pi bonds. So you can see the difference. Here it is initially 3 pi bonds is there, and in it is 2 pi bonds there. So the one pi bond is converted into sigma bonds. So that is the thing. So these are the two examples for the ring closure system. Now let us consider second part of electrocyclic reaction, that is B part, that is ring opening system. Ring opening. So the word itself says that here it is a ring opening should be there. Ring second type is ring opening reactions. So in this case it is also another type of electrocyclic reaction in which ring opening reactions is a reaction in which a sigma bond is, in which a sigma bond is a sigma bond of, sorry, these are the ring opening reaction, which is also type of electrocyclic reaction in which a sigma bond of a cyclic reactant is cleaved to form a conjugated product with one more pi bond. So see the difference. In the previous case, we consider that the pi bond is converted into pi bond is converted into sigma bond, while in this case the sigma bond is cleaved and the one more pi bond is formed. So the important point in this case is that sigma bond is cleaved to form a pi bond. Okay. Now consider the example. Let us consider the example for this type of reaction. Now we are going to consider this cyclic reaction. So now in this case this particular type of bond is clear. So I'm going to write down the mechanism. So the bond is cleave like that way. This bond is migrate here and this bond comes down here, right? And the product is, so the I'm going to number this one. So this is 1, 2, 3, and the 4 member ring is cleave into open chain type of system, that is 4 carbon atoms there in a long chain. So here it is 1, 2, 3, and this is 4. 1, the numbering should be here. This is 1, this is 2, this is 3, and this is 4. So the new bond is formed at the position 2 and 3. So sorry, 1 and 2 is there one bond, and the second bond is in the position at 3, 4. So you can see this one pi bond is there, and here it is 2 pi bonds are there. So in this case, this sigma bond is cleaved. Sigma bond is cleaved to form a new pi bond. Okay. So these things should be remembered. So let us consider another example. Now we are going to consider the 6-member ring. So this is the reactant. Again, if we are going to consider this is a ring opening type of system, so now we are going to consider this sigma bond is going to be clear. The mechanism for this one is this bond will migrate here, this bond comes here, and this bond goes here. So this can be understood in a better way that if you number the ring 1, 2, 3, 4, 5, and then 6. Okay, so this ring goes into the 6-member transition state. So we can write down the 6-member transition state also. This is the okay. Now this 1, 6 bond is there. The numbering should be there 1, 2. Sorry, let us draw the ring in a new format. This is 1, 2, 3, 4, 5, and 6. So this dotted line indicates that the pi bond is migrated through the cyclic system. Now the new bond is formed between, now look at this. The new bond is formed between 1 and 2 carbon, 3 and 4 carbon, and 5 and 6 carbon. So when we are going to write down the mechanism final product, that particular intermediate will collapse into the final product, and the product is here. So 1, 2, 3, 4, 5, 6 member ring is there. Open chain is there. So the if you look at this, bond is formed between 1 and 2, 3 and 4, and this is 5 and 6. Again, see here there are 2 pi bonds. This is the 6-member transition state, and here it is, you can look at that there are 3 pi bonds. So while when we are going to consider the ring opening type of system, I already mentioned that this 1 sigma bond is converted into the pi bond. So 1 sigma bond is converted into the one more pi bond. So that is the beauty of reaction. While in case of ring closing system, one pi bond is converted to the 1 sigma bond. So the ring opening and ring closing are exactly opposite to each other. Okay, so these are the two reactions. Now let us consider the second class of the reaction, that is cycloaddition reaction. That is cycloaddition reaction. So sorry, one more point is important here. We're going to consider that these reactions are stereospecific, as earlier said. The electrocyclic reactions are stereospecific. Electrocyclic reactions are stereospecific. Stereospecific means a specific isomer gives a specific product. Specific isomer gives specific product. Specific isomer gives specific product.